Good morning, everyone. Now let's see some examples on subsequences. In previous video, we have seen that if there is a sequence has limit L, then its subsequences also has a limit L. And if suppose subsequences has limit L, then that original sequence has also limit L. And if suppose there are two or three subsequences of original sequence Sn, and these two or three subsequences converges to different limits, then we can say that original sequence Sn is divergent sequence. So let's see some examples on this topic. Okay, suppose this is a sequence Sn. Sequence Sn we are defining 1 0 1 0 1 0 1 0 like this. Okay, so this sequence has suppose two subsequences. We can define these two subsequences to Sn S2n minus 1 is suppose 1 1 1 1 1 1. Okay, and sequence S2n, second sequence define we can define 0 0 0 0 0. Okay, so S2n minus 1, if we take limit, then this sequence converges to 1, and limit S2n, what is limit of this sequence, is 0. Yes, so what we have learned, that subsequences must have same limit for convergence of original sequence, but here we are getting different limits for two different subsequences. Okay, means we can write, since limit n tends to infinity S2n minus 1 is equal to 1, that is not equal to 0. Yes, that is 0 and 1 are not equal. These are the two different numbers that we have got the limit of these two different sequences. So you can say that this original sequence Sn is divergent. This sequence is divergent. Okay, let's see next example. Okay, suppose this is sequence Sn. Yes, and sequence Sn is what? 1 minus 60, 1 by 2 minus 30, 1 by 3 minus 20, 1 by 4 minus 15, like this. Okay, this is a original sequence. Now define subsequences for this sequence. So you can write subsequence 1 1 by 2 1 by 3 1 by 4, 1 1 by 2 1 by 3 1 by 4 1 by 5, like this. So you can write what? This sequence is nth term is 1 by n. Okay, and what is limit of this nth term when n tends to infinity? Yes, so we can write 1 by infinity, that is 0, not defined. Okay, 1 by infinity. Now we can define again next subsequence of original sequence Sn, that is minus 60 minus 30 minus 20 minus 15 and so on. Okay, so means you can write this sequence as minus 60 by 2 minus 60 by 3 minus 60 by 4 and so on. Okay, so in general nth term you can write minus 60 upon n. Okay, for all n belongs to n. And if we take limit of this sequence, so as n tends to infinity, so this implies minus 60 upon n, and limit as n tends to infinity, so we get 0. So these are the two subsequences. Yes, S2n minus 1 as limit n tends to infinity, and limit of a sequence S2n, both shows limit 0. Then we can say that limit of original sequence Sn is equal to 0. Yes, means what? We can write like this: sequence Sn converges to 0. This is not a divergent sequence. This is a convergent sequence. Okay, thank you.